It would be great if we lived in a world where I can introduce stuff in class and then students would just go and practice it on their own. That's not the world we live in. If you don't assign homework assignments, you guys won't even touch Java for long swaths of time. So like, for instance, after the semester's over, in preparation for next semester, you guys should spend like all of Christmas break, the whole winter break. So you guys like 6 weeks, right? Pick a project, write some code to do it, come back, like show it off. Like, look, I did this with all my 250 knowledge. Not going to do that. You're going to come back and wonder what a variable is. Okay. So, I don't even get it. I don't get it. All right, what was the assignment? Out of curiosity. Just JSON object versus JSON array. You stood me up at the bluff this morning.
Sorry.
I was doing backwards wind sprints. Is that a thing? Or backwards wind sprints a thing? We're training for a Ninja Warrior.
Sounds like it. Sounds hard.
Yeah, I was doing it up and down the bluff steps. They were icy this morning too. It was rough.
Backwards up the steps?
Yeah, up, down, and up. Down was tough because I'm a little top heavy. So, so with the slope and, oh yeah, so I went fishing yesterday. We finally tested the new motor we put on this weekend. Worked well, but actually it worked too well. I drove her for like 30 minutes straight, and we were going all over the place. And then I shut it off too fast when we got down to our fishing spot, like after driving it for a half hour. So I flooded the engine, couldn't get it back on, but it's fine now. But man, I caught a 5-pound smallmouth. It was giant. It was giant. I had Steve Caruso with me, but I don't think he came dressed prepared to drive around in 38-degree weather for a half hour straight. So he was just back there shivering, and I was laughing at him because I came dressed prepared. I also scared him too because I did this really tight turn in like really shallow water at really high speeds. He wasn't ready for that either. Okay, so idea is that we're supposed to kind of think about our JSON object or JSON string in terms of JSON objects and JSON arrays. So anytime we see one of these dudes as a JSON object, whenever we see one of these dudes as a JSON array, did I also say JSON value? Okay, so you just had to identify objects and arrays. Oh man, this was an easy assignment. Okay, so right now, man, why did I do that? I shouldn't have made it that easy, should I?
You're generous.
Okay, so let's see here. Let's close a couple of these things so everything fits. All right, so we already have our cave.json file there. Here's our driver. Right now, our driver is reading in that file and going through and doing that stuff. So here's the JSON file that we read in. Okay, so for right now, we built a object called CaveParser, so you certainly could have used this if you wanted to. I guess let's write the code external to this first, and then we'll embed it in there when we start doing it more in the more complex way. So we'll just use our driver for right now. So we're reading in from a file, building up a string called the JSON, and then spitting it out in the end. Let's just make sure that guy still works. Oh, I have some errors in my CaveParser. This guy is supposed to return a JSON object, so I'll just return null for right now. All right, so this guy should now print out the stuff it read in. So we're going to walk through this string one character at a time. So we're going to write our normal for loop. So for int I is equal to 0, I is less than the JSON dot length I plus plus. So this will take I on a voyage through every single thing we see in our string. And so we're going to say if the JSON.charAt I is equal to an opening curly brace, then we want to go ahead and say system.out.println JSON object. Did I screw up?
You had JSON Object begin and end.
Oh, okay. Gotcha. Begin, else if the JSON dot charat I is equal to a closing one of those dudes. We'll say system.out.println JSON object end. Else if the JSON.charat I is equal to an opening square bracket, system.out.println JSON array begin. Else if the JSON.charat I is equal to close system.out.println JSON array end. Like that. And just ignore everything else, right? So this will go through our string, spin through it, look at the character we're currently interested in, or currently looking at. We're only interested in curly brace and square bracket thingies for this assignment. And if we see any of those, we'll interpret it appropriately. So this is the output. JSON object begin, array begin, object begin, array begin, object begin, object end, array end, object end, object begin, array begin, so on and so forth. Is that the right output? All right, so that was the homework assignment. So what did you do the rest of the time you were in line at GameStop? Man, I thought this was going to be harder when I assigned it. In my head, I was in a rush.
Hard part was uploading it to Git again. Yeah, I'm gonna do all that.
Why is that hard? You should be experts with GitHub now. Yeah. Durr. Did you get it working?
Yeah.
Are you a little bit better at it now than you were before? Because now you've used it twice.
Probably.
See?
Just a little bit. My problem was I did it in the wrong folder. So it didn't detect it. It just printed it out.
Didn't detect what? The file?
It didn't detect the file. I did it in JSONParser instead of the driver.
Well, that's fine. You can do it in CaveParser. I mean, that's ultimately what I'm going to do here, is we're going to have CaveParser read in a JSON string, and then we're going to tell it to parse this guy, except, you know, all we're going to do here inside of driver is we're going to take that code, we're going to cut it, and we're going to go into CaveParser, and we're just going to paste that into the parse function right now. We'll still return null at the end because we're not actually building up these dudes yet, right? Okay. And JSON is the guy being passed in up here. So now we can go out to driver. Oop, I need to paste this back out here for a second because I cut out a little bit more than I intended. Now I have the string, and now I'll go ahead and say CaveParser CP is equal to a new CaveParser, and we'll pass it the JSON. All right, because CaveParser is expecting me to pass it a string as a parameter. We're going to actually update that here in a second to clean up driver even a little more. And then we have a function inside of CaveParser called parse. That ultimately is going to return a JSON object later on. We'll work on that some today. But for right now, it's just going to give us a null because it's going to do our little assignment thing inside of that. So now we just say cp.parse. And that guy will now have the same output as we just had. Okay. Now, similarly, we might choose to go ahead and build this stuff inside of CaveParser to simplify this even more. So I'm going to take that code. We're going to go into CaveParser. We're going to change, this guy's no longer going to take in the JSON, it's now going to take in the file name. We'll put this code in here, and right now we're passing it cave JSON as that, but we're going to have to concatenate that on now, so we'll concatenate on file name. So we'll build the same exact string, but instead of assuming it's cave JSON, we'll allow us to pass in different file names for this. We'll concatenate that on. We'll read it in. We're going to start, we already have the JSON, so we'll say self dot, or it's not self in this language, it's this dot. This dot, the JSON, starts off as the empty string, then we fill it up, and I'm going to go ahead and change all of these. Let's see, can I just do... Oh, that's not going to do what I want it to do. Hey. Oh, I broke them all? Oh, good. All right, well, we'll fix this then. I'm just going to throw this dot in front of all of them just because I prefer that. All right, and this guy technically has a throw catch, try catch. Did we talk about that at all last time? Or I just kind of glazed past it and said, let's just throw it? Oh yeah, I say throw exception. So I'll go ahead and introduce that real quick. So we'll get rid of that there. Let's go ahead and pass in the name of our file. We called it cave JSON. So that's the name of our file. And then we'll go into our cave parser. And this guy's screaming at us. One of the options is we can surround this guy in a try catch. So we can try to do this thing that might cause a problem and then potentially catch the exception, the file not found exception here. Okay, and then we can print out the error message if we get it. So this is the default try catch that they give us where, you know, this line could cause a problem. If it does, catch the problem and deal with it without crashing your program. Okay, but understand that if you're in here dealing with it, for whatever reason, this didn't happen. So this stuff down here is probably going to have problems. Okay, so I'm actually going to move all this stuff inside of the try. We're going to try to do all of this. This will all assume that input gets a real value. And if something bad happens, we'll catch the file not found exception, although I typically, unless I'm dealing with something that has a specific, like let's say I have some code in here that 2 or 3 different things could go wrong. I could have multiple catches. I can say catch file not found exception, catch array index out of bounds exception. I can catch different types of problems. This is more of the lazy catch-all that just says anything that is an exception. So all of those exceptions, file not found exception is an exception. So an exception is an error, okay? But it's an error that we can deal with gracefully inside of our program. So often I'll just say catch any exception. Anything bad that happens in here, I'm going to catch it here and just print it out in this current case. Make sense? All right, so for right now, anything that could throw an exception, you might just wrap in a try catch like this, and that is us dealing with the exception, even though we really haven't done anything special. We've just printed out the error message to the screen because that's us, following Java's rules and dealing with it. Okay? So now we have our cave parser constructors taking in a file name, It's going to go ahead and read in that file the same way we did before, except we went ahead and concatenated the file name onto the end here. So we can possibly parse multiple files now. Then we go ahead and fill up the JSON string. We can probably start our JSON string off up here if we wanted to, just to guarantee it always has a value. So now JSON will always be equal to the empty string at least. We hopefully will put some more crap in it here. Okay? When this try catch is done, the JSON value should have actual stuff in it. And what will I do with that? Well, eventually somebody's going to call parse. And we're going to be going through here, and I'm going to go ahead and put this dot in front of most of these guys. So we'll do the exact same code we did right now, for right now. And this isn't required. I just prefer to be explicit and say this dot for the spelling error stuff. So I'm just trying to set a good example here. Okay, so there's my cave parser now. We've just moved the stuff that we had in driver into there. So now in driver, we can just look like this. Create a cave parser around this file name, and then parse it. And we should get the same output. Make sense? Okay, so now we want to take this to the next step. We're already noticing when we are dealing with objects and arrays. Let's go ahead and add one more step of being able to determine when we're dealing with a value. Okay? Well, really values come in, values always start with a name or a key, right? So when we look at our JSON here, let me open that guy back up. Every one of our values, here is a value, here is 0, and it has a name associated with it. Name always starts with a double quote. Name always starts with a double quote. Name always starts with a double quote, so on and so forth. That makes sense? So now, if we see an opening double quote, we want to know that we're at the beginning of a name. So now we want to additionally detect names. Make sense? But this double quote and this double quote are identical with the same key. So if I do this the way we've done it right now, we're always going to think we're at the beginning of a name. That makes sense? Now, names are always followed by values. So we can't read in a name without also then expecting a value. Does that make sense? So again, we're kind of throwing the structure in here. We're not actually building these objects yet. We'll do that here in a few minutes. But if we're going to read in a name, we also need to read in the value because those guys come together. A name doesn't exist without a value, and a value doesn't exist without a name. So this whole little cadence here comes in one fell swoop. Does that make sense? All right. So, but what we're going to do here is, in order to handle, we're going to start this with our just our name value pairs, just to prove this works. We're going to make our cave parser kind of modular. So we're going to write a function in here. Public. Let's see. For right now, we'll just have it be void because we're printing stuff out. Okay. And we're going to call this guy get name val pair. All right. So whenever we hit an opening parenthesis, an opening double quote, we want to get the name value pair associated with that. Make sense? Okay. So we're going to call this guy. Now, one thing we're going to have to now do globally is we're going to have to remember where in our string we're currently standing. If we're going to be turning over parse control to various functions inside of cave parser, somewhere globally inside of cave parser, we need to know which character are we currently on. Okay, so that all those guys can share that variable. All right, so I'm going to change this up a little bit. We're going to say, actually, I'm going to cheat a little bit with our inside parse. I'm going to refactor I. rename this, and we're going to call this guy curpause. Okay, so now that guy's done. Now I'm going to not define curpause there. Instead, I'm going to define it here at the top. Private int curpause. All right. And then when we start parsing, we'll go ahead and initialize curpause to 0 and go to town. Okay? And we're going to be piecing this stuff out here in a second. But what I'm going to do here is let's just add the else if that helps us with this. So else if this dot the JSON dot char at curpause, if that guy is equal to a double quote, then what are we going to do? This get name val pair. That's what we do. Call that function. Okay? And we're going to see we're going to make the rest of this similarly modular. All right. So get name val pair is going to call this function right here. Now, curpause will be controlled by our loop right here, but we might change the value of curpause in here. So right now I've directed control over to this other function, the get name val pair function. Okay, and this function or method, whatever you want to call it, this guy now knows that the current character pause is curpause. Okay, and that it is sitting at the opening double quote of the name. Make sense? All right. So we're going to, for right now, still just deal with the structure of this. So right off the bat, we're going to go ahead and print out name begin. Okay? So we'll do a system.out.println name begin, because we're at the beginning of a name. Now we're going to go on we're going to increment curpause by 1. We're going to bump it forward 1, right? We just digested that first opening double quote. So we're going to say this dot curpause plus plus. So this burns past the starting double quote for name. That's what that line does right there. Okay? So we burn past that guy. Now our job is to read in the name. So that's what we would do next. Okay? My Slack is just blowing up. Okay? Would be to read in the name. That's what should happen next. And then what do we, so right now we're not going to actually collect the name, but what we're looking for next is the closing double quote. Correct? So we'll put it in a little thing. We'll say read in the name. Then, well, here, let's just do this. Read in the name until we hit closing double quote. So, while this dot the JSON dot char at this dot curpause is not equal to the empty string. I'm sorry, not the empty string, the single quote. A single double quote. Well, it's not equal to what I typed, which is a single double quote. Well, it's not equal to that guy. What are we going to do? We're just going to keep advancing. Okay? So we'll say this dot curpause plus plus. So we're just jumping until we finally land on the closing double quote. And what do we say when we land on the closing double quote? We say name end. All right, then we need to burn past the ending double quote for name. Next thing we're looking for is the separator, that colon. Now there's no guarantee it's going to be the very next character. We might have white space in there. Okay, so now we're going to, so let's space this a little bit. So we'll read in the name until we hit the closing double quote. Now we're going to burn past, well, let's just say find the colon separating the name and value. All right, so while we already burned past the opening double quote, so now we know we're going to have potentially white space until we get to the colon. So while this dot the JSON dot char at this dot curpos is not equal to a colon, this dot curpos plus plus. Okay, now right off the bat, wouldn't you say that this code and this code are the same code? And what were we trying to do with that? We were advancing to a character, correct? So couldn't I write that in a function and have it allow me to pass in the character I want to advance to? So we'll write and actually this guy's going to be private, get name value pair. So I'm going to say private void advance to next char C. I will steal this code right here, and instead of it being that guy, we're going to be comparing it to C. So what do we do now when we want to read until we hit the closing double quote? Well, what we're going to do is we're going to say this dot advance to next char double quote, and that will get us to that guy. Similarly, I can say this dot advance to next char, but this time I'm looking for a colon. That makes sense? And if I want to print this out just for completeness, we can say system.out.println name value separator, just to kind of prove that we're kind of hitting all the structure. All right, so name value pair, we know we're only here if we're at the beginning. So we'll say name begin, burn past it, advance to the close, right? Say we're at name end, burn past it, advance to the separator, same name value separator, burn past it. We actually wouldn't have to burn past that one, but let's just keep with the cadence, I guess. Well, it's literally a waste of time to burn past it, so we won't keep with the cadence. So next thing we're looking for is the beginning of the value, right? Now, for right now, the beginning of the value could be what? Well, beginning of the value could be a double quote. It could also be, I think in ours, we kept it fairly simple, right? Oh, no, we do have just integers. All right, so here's an example of a value. Here's an example of a value. Here's an example of a value. So a value can be a literal, a value could be a string, a value can be an array, or the value could be an object. I don't know, do we have an example of that? We don't have an example of a value being an object, but it could be, where this is an example of an object. Okay, so the value could be any one of those guys. Okay, so now, if we're in Cave Parser, after I've hit the separator, I now need to get the value. Okay? So when I say get name value pair, this guy is going to go ahead and get all the way up to this point where we've read in the name, but now we need to get the value. And the value for this guy could be all sorts of stuff, right? It could be any one of these other guys. So as I'm walking along, if I hit a opening curly brace, my value is a JSON object, right? Now let's look, before I go any farther there, let's look at the structure of our JSON code here. Every JSON program always, JSON string always starts with an opening curly brace. And an opening curly brace always means we're creating a new one of a new what? What kind of animal are we creating whenever we hit an opening curly brace? JSON object. We're creating a new one of those. So no matter how long or complex a JSON file is, it will always boil down to a single object that is a JSON object. Now that object might have some really complex stuff inside of it, but at the end of the day, it's still just an object. Okay, so we'll always start with that first object. Okay, and then as we hit that first object, what's the very next thing we run into? We'll try to get a name. Okay, then we'll try to get a value. And we're going to keep doing this over and over again until we finally hit the corresponding closing curly brace for our opening JSON object. Make sense? So, I'm going to go ahead and we're going to create a new file for right now. And we're going to call this guy simple JSON. All right, and we're going to give ourselves a simple JSON file that doesn't have arrays, doesn't have more than the top level object in it. It's just a bunch of name value pairs. Okay, we'll start simple with that. All right, so file's going to look like this. And let's call this 1 is 1, 2 is 2, and 3 is 3. So that's our file initially. Okay, so let's go back here to our driver, and we're going to have this guy no longer take in a file named cave.json. It's now going to take in the file named simple.json. It's going to parse a different file. Okay, now this file is not a good example of a complete JSON file. It's an extremely simple JSON file, but it is a legal JSON file. Okay, but it's going to be the easiest one for us to initially parse, and then we'll go from here. But this will get us working with our objects. So I'll go in here to CaveParser, and we're going to go ahead and just gut this. Say we don't need this anymore. Okay. Now, if we look at our JSON here, where did I put this guy? Here's our simple JSON. This guy is a JSON object. That's what we would call him, right? A JSON object. Now, a JSON object is a collection of name value pairs. Okay, so it's going to be a collection of JSON values. Fair enough? We can call this guy a JSON value, and every JSON value has a name and a corresponding value. Okay, or maybe we call this a Json variable. Maybe that's the better name. All variables are name value pairs. All right, so why don't we call this guy a Json variable? So we've currently created a JSON object and we've created a JSON array. Let's go ahead and give ourselves a new class called Json Variable. Okay, now a JSON variable in our world is going to be pretty simple. It's going to have a private string name, and it's going to have a private, for right now, since we just have our simple JSON file is just a, let me get rid of room, get rid of player, good enough right now. Since right now all of our values are always strings in our simple one, we're going to say the value associated with the JSON variable is a string. Fair enough? So this is going to be a string value, even though we know fast forwarding it's going to become more complex than just a string. All right, so JSON variable is going to be a name value pair. All right, and then we'll go ahead and create the constructor for this. And this guy's going to take in a string name and a string value, and it'll set this dot name equal to name and this dot value equal to value. And that's all he'll do right now. Let's just say that's good enough. We'll add some features to him later on. Okay, so we just created an object that's capable of holding two pieces of information for us: the name and the value associated with a JSON object. Now, what's a JSON object? A JSON object is going to be a collection of JSON variables, right? Based on what we know right now, how do we create collections of things? If I want you to hold a collection of integers, what would you build? Build an array. That's our collection type right now, right? If we want to hold a bunch of integers, we put it in an array. If we want to hold a bunch of chars, we put it in an array. If I want to hold a bunch of strings, I put it in an array. If I want to hold a bunch of JSON variables, I'll put it in an array. All right, so our JSON object is going to control an array of JSON variables. So what's the syntax for an array? It's type, let's make it private here, JSON variable. Then you put the open close square brackets in it. So this is going to be a JSON variable array called the variables. And then let's make our constructor for this JSON object. Okay, we're going to have this guy take in no parameters. And it's going to go ahead and set this dot, the variables, equal to a new JSON variable array of size what? Now this exact moment right now is the precursor to CSC250 the next semester's class. Where do arrays become weak? How many variables will a JSON object be able to hold? Well, how many name value pairs will a JSON object hold? Could be 0, could be 5, could be 3, could be 3,000. We don't know. At this exact point in time, we don't know. So, how big do we make this array? We got a couple of choices. We can make it big enough to hold what will likely be the maximum size, and then keep track of how many things we've actually stored. We could make it tiny, maybe starting off as empty, and then as we need to make it bigger, destroy the old one and add new things, right? All right, so certainly this is a limitation of arrays. And we're going to learn how to go past this limitation next semester. But right now, we're just going to stick with the limitation. Okay? So we have this limitation. So because we're kind of building this guy to fit our cave JSON parser, we're just going to arbitrarily pick a maximum number of values that our JSON objects are capable of holding. Okay, so what do you think the maximum number of name value pairs our JSON object should be capable of holding? 50? Is that fair enough? 50 is fair enough. We can always adjust it later. So we're going to say this guy is allowed to hold 50 things max. Okay? Which means now we're going to have to keep track of cur size. So we'll say this dot cur size is equal to 0. This guy is a container capable of holding 50 things. Right now there's 0 things in there. So the very first thing we'd add there is going to go at bucket cur size. But then bucket cur size goes up by 1. Make sense? And what kind of animal does this guy hold? This guy holds JSON variables. So we're going to go ahead and give our JSON object the ability to add a variable. And this guy will take in a JSON variable, JV. And this guy will say, well, we'll probably want to ask the question, if this dot cur size is less than this dot the variables dot length. As long as I have room, right? As long as I have room, I'll go ahead and say this dot, oh, this guy's going to be a void. I'll go ahead and say this dot the variables at bucket, this dot cur size is equal to our variable. And then this dot cur size plus plus. So we've given an ability to our JSON object to add a new variable. Okay? Now, so far, we're adding a whole bunch of little classes. Treat each of these like a Lego. Okay, these are each Legos. We built a Lego that knows how to hold JSON variables, called a JSON object. We built a Lego called Json Variable, where's this guy, that knows how to hold 2 strings. All right? So even though this starts feeling unwieldy in terms of the number of objects that are floating around, none of these objects so far are overly complicated. Okay? Just treat each of these objects as a little bucket for holding a couple of pieces of information. Okay? So we know how to add a variable to our JSON objects. And we're going to say that's okay for right now. So as we're building up JSON objects, we're going to be just stuffing stuff inside of them. All right, we'll figure out how to display them later. All right, so that's our JSON object. So right now, in terms of simple JSON, we have one object, which is all we're going to say we're allowed right now. And inside here, we can have a maximum of 50 name value pairs, because that's what our code supports, right? So 3 is within that maximum. We're okay with this. So as we walk through here, we're always going to start off by creating a JSON object. That's the very first thing we do when we start parsing a JSON file. And then we add things to that object. That make sense? All right. So let's go back into our cave parser. So here's our parse code. All right. And our parse code says to do what? Well, we just said that we're ultimately going to create a JSON object. We'll call this guy the object. He's going to be a new JSON object. And in the end, we're going to return the object after we've finished building him. So then what happens in the middle? We have to start reading in our variables. Okay? And how do we get variables? Well, we get variables by maybe writing a function. Let's get rid of this guy for right now. We'll keep this advanced to next char for a moment. Okay, we'll see if we need him. So how do we get a variable? Well, let's go ahead and give ourselves a private function called getVariable. All right. So getVariable is going to start off at our current pos, and it's going to get a variable. Okay, well, in order to create a variable, what do I need? I need a name and I need a value. Make sense? So let's go ahead and get our name. This guy down here, our parse, he's going to start the ball rolling to get our JSON object. Make sense? So we're going to say, in fact, actually, let's do, I'm going to do this for starters, so we potentially will return a null value. Then we'll start our loop for int I is equal to 0. I'm sorry, not int I. for this dot curpos is equal to 0, this dot curpos less than this dot the JSON dot length, this dot curpos plus plus, we'll do this. Now, the reality is this is probably a poor structure for our parse. The reason it's a poor structure is we're going to run into some issues down here as our for loop changes the value of curpos. So now we got to play this game as we're kind of passing control to our other functions, and those functions change the value of curpos. Curpos also is going to be changing its value here. So we kind of run the risk of curpos getting off by 1 unless we're very careful. All right, so we might decide to treat this part of the code as we don't know how long it's going to run for, but it can't go off the end of our string. So maybe we say this dot curpos is equal to 0 to get the ball rolling here. And then we say, and I didn't say that up here, did I? Okay. And then we say while this dot curpos is less than this dot the JSON dot length. Keep doing this as long as the current value of curpos, whatever it is, however it got to that position, is still a legal position. That makes sense? All right, and what's the very first thing we're going to do? We want to move to the opening curly brace. Okay, so in our world right now, we can go ahead and assume that whoever's passing us this code is giving us accurate JSON. Okay, so we happen to have a handy dandy little function, advance to next char. So we're going to go ahead and say this dot advance to next char. The char we want to advance to is the opening curly brace. And once we get to there, we know we can go ahead and give our object a value. All right, so go ahead and go to the beginning of the object, then create the object. We have the variable for holding the object up here, but we actually gave it its value as a JSON object right here. Make sense? Okay, then what are we going to do? We are going to start reading in the name value pairs. Make sense? All right, so what do we want to do with the object? We want to say the object dot add variable. What variable do we want to add? Whatever's returned by this dot get variable. That function. This should add one variable for us. Then we'll see how we can call this multiple times. Okay, so we'll add one variable. So what does get variable do? Whatever we call this guy, the idea is that we're going to be calling this guy with the understanding that we have a variable to read in. Wherever we're currently sitting in the string, the next thing we expect is a variable. And variables require two pieces of information. They require names and they require values. Okay? So, what are we going to do? Well, we're going to build a string for holding the name and a string for holding the value. We need to go ahead and we're going to start getting our name. In fact, let's just kind of do these guys in sequence. So we'll create a string for holding our name. Then we want to say this dot advance to next character. The character we want to advance to is the opening curly brace. Make sense? Okay, now that'll get us to the beginning of our name. Now we want to read stuff in until we get to the end of that name. And the end of that name will be when I hit my next double quote, right? But I can't advance there because I actually want to collect the name in the middle. As I'm going through this guy, so I've advanced here, and then I said, okay, well, I'm going to start my object now. Okay? Then I advance here. So now I'm saying I'm going to start my name. Now I have to start collecting characters inside of my name string until I finally hit the closing guy. So the next guy I'm looking for is going to be the closing double quote. But I don't want to just randomly advance to him. I need to collect the crap in the middle. Make sense? So I'm going to keep concatenating on characters that I read in until I finally hit that closing curly brace or closing double quote. How many things am I going to have to read in before I hit that closing double quote? 1 character? 10 characters? 1,000 characters? We don't know. Kind of loop lends itself to the kind of problem where we need to do something a number of times that we don't necessarily know. While loop. While loop lends itself to this. So we're going to say while. Now keep in mind, we're currently sitting at that opening double quote. So we need to burn past that. Okay. So maybe what we do, I'm actually going to, just to keep this relatively modular, I'm going to create a second version of this function. Almost the same. This one's going to be advanced past next character. And what this guy is going to do is he's going to call advanced past, or he's going to call advanced to passing it the same thing, and then we're going to say this dot cur pause plus plus. So I have 2 functions here. One that takes me up to including a particular position, particular character, and the other one takes me 1 past it. Okay, depending on whether I need it or not. So in this case, I need to pull myself into position where I'm ready to start collecting values. So if I'm currently sitting right here, I need to advance past that guy, leaving me sitting right here. Make sense? And then I want to start collecting stuff inside of name until I finally hit this. So we're going to say, instead of advancing to that opening quote, we're going to say this dot advance past the first double quote. Then while this dot the JSON dot char at this dot cur pause is not equal to that guy. All right, while it's not equal to that guy, I can go ahead and what? Start collecting. Name is equal to name concatenated with this dot the JSON dot char at this dot cur pause, and then this dot cur pause plus plus. Make sense? All right. Now, this will go through and it will collect all those characters between those 2 places. And we'll build it up inside of our string name. When I'm done with this while loop, where will I be sitting? I'll be sitting right there at the closing curly brace. Have we talked about substring in here yet? Okay. So we have a function called substring from the string class that allows us to get parts of a string. Correct? So let me ask you this. If I had the current position of this, well really, let's say I had the beginning position here, and I wanted to get everything up to but not including this guy, couldn't I go ahead and remember where I was here and then advance to this guy and then get the substring in the middle? I could. So I can do this actually inside of our cave parser. instead of burning this, let's go back here. I can go ahead and grab inside of get variable, let's just have an int pause in here. And I'm going to say pause is equal to this dot cur pause. The current value of cur pause is the value of the beginning of our name. Make sense? That's the beginning of our name because we are currently sitting at the thing right past the double quote. Then I can go ahead and say this dot advance to the end of the name. Just steal that there. And now I can say string name is equal to this dot the JSON dot substring. And the begin index is going to be pause. The end index is going to be this dot cur pause. And the end index is not inclusive. But the good news is that's fine because I'm actually sitting right here. So I'm saying give me everything from here to here, but not including that last guy, which should give me that name. Make sense? So I'm going to use Substring, that tool, to go ahead and grab me things in that range. So now I've leveraged my Legos. So I keep building myself these little tools from Home Depot, right? Okay, so I said, oh well, let's go ahead and let's solve our problems in terms of these advance to next and advance past next character. I'll go ahead and use this screwdriver that was given to me by Java called Substring. Okay, so I have all these little tools that I can now use and kind of apply them to the types of problems I'm solving. So we're going to keep track of the beginning. So that's what this guy says is, remember the pause of the beginning of the name. And then this guy goes ahead and grabs the substring from the beginning of the name all the way up to the position right past the end of the name. Make sense? So this code right here should get my name. Now what? Well, now we want to go ahead and we want to advance what? We got to get to our separator. So if we look at our simple JSON here, I'm currently sitting right there. Cur pause is right there. So I probably want to go ahead and advance to that position. We're not going to use it, but we'll go ahead and advance to that position. That is guaranteed to move us past the end of the current thing, rather than just putting in a plus plus or something like that. All right. So we'll go back in here. So now let's go ahead and move to the separator. This dot advance to next character. So now we're right there. Okay, now what will we do? We're going to do this, then do this, then do this. Same exact things we did before. So after we've moved, so this is read in name. This guy is read in value. So once we've moved to the colon, we're going to move past the opening double quote for our value. Remember that position. So this is the beginning of our value. Then advance to the end. And then instead of reading in the name, we're actually reading in the value. Make sense? Okay. So now, I can go ahead and create, since I have a name and I have a value, I can go ahead and create my JSON variable. So we could say JSON variable, the variable is equal to a new JSON variable, and this constructor takes in a name and a value right there. So I can go ahead and build that Lego, passing him the name and the value I just read in, and then I'll return the variable. All right, so this is get variable. Get variable uses a little local counter, grabs the name, moves to the separator, grabs the value, builds a variable out of that name and value, and then returns it. Who called this guy? Parse called this guy. Parse started walking through our string. It read in this guy. Then it got an object. Okay, as soon as he hit that opening curly brace, we got an object. Then we added a variable, a single variable. Okay? Now, at the end of reading in that single variable, what is my string going to look like? After I've got the value, I'm sitting right here. Make sense? Now, the next thing I'm looking for is either a comma. What does a comma tell me? If I bump into a comma next, what do I know? I have another variable. Okay, if I bump, so it's not the end of the variable necessarily, it's the fact that I have another one. Because here's the last variable in here, right? No comma. So when I finish this guy, I never hit a comma, which says there are no more variables. So commas tell me I gotta go digest another variable. So I need to look for a comma, but I might not get one. So what happens? So let's go back to our advanced functions here. If we try to advance to a character and we don't find it. So right now, we just keep walking. Let's say I'm looking for a question mark. Okay, we can all agree no question marks in this code. So if I call advance to question mark or advance past question mark, what's going to happen in my program? I'm going to get an error because the very first time I try to get the character at an illegal position, it's going to scream at me, right? So I need to ask a question in here, well, inside the loop. If I run off the end of the string and I didn't find that guy, well, then that means I'm done. Can I write a function instead of crashing out? Can I write a function that asks the question, is there this kind of character coming up? All right, so could I say Boolean, let's do a Boolean for this. Let's think about this. What's going to be the most helpful for us? Asking if the next comma comes before. Well, let's just do it. Let's do some singletons here. So Boolean is let's do it this way. Exists char C. All right. So exists char C is going to return a Boolean. We're going to go from the current starting position in our string, potentially all the way to the end. And if I ever find something that matches C, I'll return a true. Otherwise, I'll return a false. So this allows us to ask, is there a comma, without actually adjusting the position of curpause. Because curpause is keeping track of where we're currently sitting inside of our JSON string. So for int I is equal to this dot curpause, Keep going as long as I is less than this dot the JSON dot length, I plus plus. If this dot the JSON dot char at I is equal to C, return true. Otherwise return false. So this function picks up where we left off, but it does not change curpos. So it sets I equal to the current position of curpos, keeps going potentially all the way to the end of the JSON string, incrementing itself each time, and if I bump into, in our case here, we're going to be looking for a comma, this will return a true. I found one. Okay? So if that's true, we'll return true. If I search the rest of the string, I don't find it, I'll return false. Okay. So let's go down here to our get variable. I'm sorry, not get variable, our JSON object parse. So we opened up our string, or opened up our object rather. Then we created our JSON object. Then we went ahead and added a variable. Next thing we're going to do is we're going to say if this dot exists, comma. If there is a comma, what do we want to do? Let's move to the comma and then do what? Add a variable. Make sense? Because we know there's another one. So if there's a comma, let's go ahead and we're going to go ahead and say this dot advance to next character. We know a comma exists. Therefore, we'll advance to the comma. Then we'll say the object add variable this dot get variable. Okay. Now, this will get us a second variable. How do we get, well, I say an unlimited number of variables, 50 in our case, right? So we can have up to 50 variables. So for our homework assignment, I'll give you this code as a starting point. We need to go through and modify this code here inside parse so that it continues collecting variables as long as there are more variables. All right, so you'll have to adjust this while loop a little bit because we can't just in perpetuity go through this linear logic and say, add a variable, is there a comma, add a variable, is there a comma, add a variable, is there a comma, over and over and over again. Could do it up to 50 times, I suppose, and then we've technically gone up to our limit, but we really want to keep reading in variables as long as there are variables. Make sense? We want to keep reading in variables as long as there are variables, or another way of saying it, we want to keep reading in variables as long as another comma exists. Okay, so I'll go ahead and push this to GitHub. I'll put the assignment up on Blackboard right now. You'll have this as a starting point, but for right now, we're updating this parse method to continue to get variables as long as there are variables. Not a whole lot of code you got to write, but I want you to think about it. Okay, so I'll put that up now, and I will see everybody on Thursday.